Hello everyone, I'm going to walk you through my design and implementation of part 2 of the traffic controller system. The core task was to design a state machine that generates the green, flash, and pedestrian green signals based on a specific priority of 3 buttons inputs, which is the train, pedestrian, and car. So let's begin with the priority controller state flow chart. So this is the central piece of the design. I'll call it the priority controller. This chart is responsible for implementing the strict priority logic defined in the problem statement. The inputs to this chart are the 3 buttons, which are train, pedestrian, and car. So the highest priority here is the train, which is so if the train is equals to 1, the system transitions into the train state. In this train state, I set the green is equals to 0, pedestrian green is equals to 0, and most importantly the flash is equals to 1. The flash signal is used to trigger the 10 Hz flashing required for the red and amber lights which you currently see in the system. So the medium priority is pedestrian and the lowest priority is car. So the signals generated by the priority controller, the green, flash, and pedestrian green, are then fed as inputs into the second state flow chart, which is the light controller. So this chart actually manages the actual sequence of the traffic lights and the timing of the flash. So the main states are the green light, the flash red, the flash amber, and pedestrian green. So the green light state, this is where the main street's green light is active. When the flash is equals to 1, the system alternates between flash red and amber as we currently see. I use this condition to implement the required 10 Hz flashing, since the period for 10 Hz is 1 out of 10, which is 0.1 seconds. Spending 0.1 second in each state effectively toggles the red and amber lights at that frequency. So let's take a look at how the pieces integrate in the main Simulink block diagram. So the inputs are the 3 toggles, which you can currently see here, which are connected to the constant V blocks representing the car, the pedestrian, and the train. So the first subsystem block implements the priority controller, which is chart 1, and outputs the control signals. So these signals are then fed into the second subsystem block, which I will call it the light controller, which is actually the chart 2. So the output of the light controller V0, V1, H0, and H1 are then routed through demultiplexers to control the individual red, green, and amber lights for both the vertical and horizontal streets, as well as the pedestrian green lights, which are visually represented by the LED-like scope blocks on the right. This arrangement successfully integrates the priority logic, flashing sequence, and the light control to meet all the requirements of the design task. So that is all from my side. Thank you.